Let's say you've constructed a tool to measure a person's level of self-esteem. Let's say it's measured on a scale from 1 to 10. You hypothesize that there's a difference in level of self-esteem based upon whether you have a job or not. In this example, level of self-esteem is the dependent variable that is continuous. You can calculate a mean on the data you collect on this variable. Employment status would be the independent variable. You are hypothesizing that the answer to the question of whether someone is employed or not may affect, or influence, or change a person's answer on the self-esteem variable. For a t-test to be an appropriate statistical test, the independent variable must be gathering nominal or categorical information, and it must be a dichotomous variable. It can only have two possible responses. In this case, a person is only employed or unemployed. If you had a polytomous variable with more than two possible responses, you can still compare means, but you use analysis of variance, ANOVA, which is another statistical test. But we're talking today about t-tests, which is a statistical procedure used to examine differences between two groups who are scored on the sample continuous variable. This allows you to analyze the data of a comparative research question or hypothesis. Really, what you're doing is comparing means between two groups to see if observed differences are statistically significant. You are looking for differences in means between two groups. For this video, we will look at the two types of t-tests, independent samples and dependent samples, how to calculate a t-test, and making the decision to accept or reject the null hypothesis. There are two types of t-tests, and they differ based upon how you collect and record your data. The first is independent samples t-test. Let's say I want to measure self-esteem for two groups. In our example, I want to know if there's a difference in the mean of employed individuals and the mean of unemployed individuals on the variable of self-esteem. These two groups are independent of each other, so we would use an independent samples t-test. However, let's say I wanted to measure self-esteem at two different times of your life. I could ask you the question at the beginning of your college career and then ask you the same question again at the end of your college career. I want to measure the differences between time 1 and time 2, and I want to connect that difference back to you. So I will have to keep the data I collect in the same order so that I compare your answers up and not get them confused with someone else's answers. This is why a dependent samples t-test is also called a paired t-test. In this test, rather than employment being the independent variable, time is the independent variable with two levels, time 1 at the beginning of your college career and time 2 at the end of your college career. For this discussion, let's assume that we're using an independent samples t-test. To calculate the t-statistic, you'll need to identify the null hypothesis. Remember that the null hypothesis is that there is no difference between the means of the two samples. The degrees of freedom, which is the number of observations in the first group, minus 1, plus the number of observations in the second group, minus 1. You will also need to know your desired alpha level so that you can look up the critical t on a table, and so yes, you will need to have the critical t-values table. Just as in the case of chi-square and other statistical tests, the critical t-values are what you use to assess whether the difference between what you observed, in this case the mean differences, and the difference between what you would have expected if the data were normally distributed, is significant. And of course, you'll have to calculate t, and then make a decision to accept or reject the null hypothesis. Just as in the case of chi-square, if your calculated t is higher than or equal to the critical t, then you reject the null hypothesis and accept the alternative hypothesis that there is a statistically significant difference between the two groups. If your calculated t is lower than the critical t, however, then you have to accept the null hypothesis and conclude that you can't claim that there is a statistically significant difference between the scores of each group. To calculate a t-test, you'll need to be able to calculate the mean of each group, the sample size of each group, and the squared deviations of each group, which we'll get to in a moment. You'll recall from earlier discussions that a distribution curve has two tails, one on either side, and you can specify a one-tailed or a two-tailed test. The one-tailed test is more stringent and allows less room for error, and that's the one that we will be using for our discussion today. Okay, don't get intimidated by this rather imposing formula. You know how to do this. You can calculate the means for each of the two groups, so the numerator is the difference between the two group means. The formula under the radical, the square root sign, isn't difficult either, starting with correcting for group variance. You will take a score from the first group and subtract the group mean from it, squaring what you got. Then you do the same for the next score and the next, etc., until you've done every score in the first group. Then sigma tells you to add all of that together. Then you do the same for the second group. Subtract the second group's mean from the first score in the group, then square it, and do the same for all of the other scores, and then add them together. Then you need to correct for group size. The number of observations in the first group plus the number of observations in the second group minus 2. Then you continue by calculating the second part of the equation, which is the number of scores in the first group plus the number of scores in the second group, divided by the number of scores in the first group multiplied by the number of scores in the second group. Multiply as shown, calculate the square root, and then finish the equation. Okay, let's do this, using a hypothesis that unemployed individuals watch more hours of television per week than employed individuals. You collect data from 10 individuals and find the following results. First, the easy part. Let's count how many observations there are, the n, which is 5. Then we calculate the mean of the first group. 3 plus 1 plus 4 plus 3 plus 5 equals 16. Divided by the n of 5 is 3.2. That's the mean of the first group. Then we subtract the mean from each score in the data set. So 3 minus 3.2 is negative 0.2. 1 minus 3.2 is negative 2.2, and so on. Then we square that. Negative 0.2 squared is 0.04. Negative 2.2 squared is 4.84, and so on. Remember that I said earlier that you had to compute the mean, the n, and the squared deviations? This is the squared deviations. Now the sigma comes into play. We need to add all of these scores together, which gives us 8.8. If you've got the concept here, it's really just a matter of doing the same thing for the second set of numbers. We have an n of 5 for this group too, and the mean is 5.2. We subtract the mean from each score, then square the result, giving us the squared deviations. And we add those squared deviations to get the sum of 2.8. Now we have everything we need to plug into our t-test formula. The mean of group 1 and the mean of group 2, the sum of the squared deviations for group 1 and group 2, and the sample size, or the n's, of both groups. Now it's just a matter of doing the math. 3.2 minus 5.2 is negative 2, and 8.8 plus 2.8 equal 11.6. And then 5 plus 5 minus 2 is 8. Continuing, you have 5 plus 5 equals 10, and 5 times 5 equals 25. Simplifying even more in the denominator, 11.6 divided by 8 is 1.45, and 10 divided by 25 is 0.4. Continuing, 1.45 times 0.4 is 0.58. Taking the square root of that yields 0.76. The final step, negative 2 divided by 0.76, finally yields a calculated t-score of negative 2.63. Okay, the last step is to compare our calculated t to a critical t. First, don't worry about the negative sign. It only showed up because the mean for the first group we calculated was lower than the mean for the second group. If we had switched the order of the groups and calculated for unemployed individuals first, it would have been a positive number. I gave you the formula for degrees of freedom earlier. The number of scores in the first group minus 1 plus the number of scores in the second group minus 1. In this case, degrees of freedom is 8. Assume you are looking at an alpha level of 0.05. To find the critical t, find where 8 degrees of freedom intersect with the one-tailed 0.5 alpha level. 1.860 is our critical t. Now it's decision time. Do we reject or accept the null hypothesis? Remember that if your calculated t is greater than or equal to the critical t, you will reject the null. Otherwise, you'll accept it. In our case, the calculated t of 2.63 is greater than or equal to the critical t, and therefore you would reject the null. What we're saying here then is that we are 95% confident, remember our alpha level of 0.05, that our hypothesis that unemployed individuals watch more hours of television than employed individuals is supported by our data. Processing time. Can you explain when you might use a dependent samples t-test? What data do you need to compute to plug into the t-test formula? Remember, you'll need the mean for each group, the sample size of each group, and the squared deviations for each group. What is the formula for squared deviations? It's the difference between each score and the group mean for that group, squared. Remember that you need to add all of the squared deviations in the group to get the summed squared deviations to use in the t-test formula. Finally, just a reminder, you only use the t-test when you are comparing means between two groups. The independent variable can only have two categories, such as employed or unemployed, male or female, etc. That means that I could calculate a t-test on your level of understanding of t-tests. If I measured understanding as a continuous variable, and whether you watch this video or not, as my independent variable, it only has two levels, whether you watched or not. But I guess I'll calculate this one another time.